All right, we are going to get started talking about surface area of triangular prisms today. Yesterday or the previous lesson, we were working with rectangular prisms and cubes. And today we're going to still be working with prisms, meaning that they will have a flat front and a flat back, but we will also be looking at triangular shapes instead. So I want to go ahead and just take a look at this net right here for this first triangular shape. And I want to remind you that anytime you're working with a prism, there is going to be a front that has a congruent back to it. So we can easily see that we've got a front and a congruent back that are both triangles here. The other thing with triangular prisms is that because it's a triangle, if you think about a triangle has three sides, so that means a triangular prism is also going to have three sides going around it. So I'm going to go ahead and highlight in orange right here. A triangular prism will always have a bottom, and so the bottom is going to be what's connecting those two triangles. And then a triangular prism is also always going to have two sides. So you can see I've got this side here in blue that kind of gets like peeled down on the right-hand side. And then on the back side of that, there's also this side right here in blue. And that's that left side that's going to get pulled down. Now, just like with rectangular prisms, you can absolutely do surface area using nets. But again, I feel like you can sometimes lose the numbers and get them in the wrong places, and it leaves a lot of room for error. So instead of trying to label out and find the area of this net, what I would actually like to do is go ahead and actually like you guys to flip to the next page. And on this next page here, we've got some examples, no nets in the way for showing our work. And we can go ahead and start at the very top with number 5. And we are going to practice finding the surface area of these triangular prisms, kind of using a similar concept to what we did with the rectangular prisms. And me personally, I always like to start with my two triangles. So a triangular prism is always going to have its two congruent or equal sized triangles. And I'm going to go ahead and I'm going to start with those. So I'm going to abbreviate triangle as tri, but then I'm going to put times 2. So I remember there are two triangles, so I have to multiply by 2. And so what I'm going to do is I'm going to find the area of one triangle and then simply double it because there's a front and a back. So for area of triangles, remember we always start with that 0.5 or that 1/2. So I'm going to say 0.5 times by. Now, for a triangle, we always need the base and the height of that shape. And remember, the base and the height should always form a right angle. So if I look at the front of this triangular prism, there are no right angles, so this is not going to help me. But if I look at the back of this triangular prism here, I see a right angle. And so this is what I need for my base and my height. I can easily follow that height up, and I can see that the height is 8 6/10. So I'm going to multiply by 8.6. And then if I follow my base across, there is no exact label that goes with this base right here. But if I follow this forward, I can really easily see that this is 10 millimeters wide. So I know that that is 10. So I'm going to multiply those three numbers. And I am getting one triangle has an area of 43 millimeters. But then because I have two triangles, I always have to double it, front and back triangle. And so my two triangles end up being 86. Now from there, I'm going to go ahead and I'm going to look at the bottom of this shape. So I'm going to just call that literally the bottom. It's a bottom, it's a rectangle. You could call it a rectangle, but this is going to have so many rectangles. I want to be specific and refer to it as the bottom. And so I'm going to go ahead and I'm going to highlight in orange right here that my bottom rectangle is 10 millimeters wide. and 18 millimeters long. And unfortunately, these problems, we can't do any underlining to help us remember which ones we've used and which ones we haven't. We have to really visualize these prisms. So I'm going to multiply 10 times 18. And I am getting 180. Now, you do need to be careful. We don't necessarily have to just multiply by 2 or anything like that, because if you think about it, we don't have a top that's the exact same size as that bottom rectangle right there. So you're really going to have to use some critical thinking about what sizes are congruent and when can we multiply by 2 because there's 2 of them, or when do we just have to leave the number as is because there's only one of it. So my bottom, there is no top that's exactly the same size, so I'm just going to say my bottom is 180. So then what I'm going to do is I'm going to look at my sides. So I've got this back side right here that I will highlight in blue for you guys. And so I am literally going to call that the back. Oops, it's supposed to be blue colored. Oh, come on, blue is not sticking. There we go. So the back of my shape here, I can see is, this is the height of the rectangle, so 10, and then the length is 18. So again, it's 10 times 18. So that's a quick and easy one for us to do, 180. So it did happen that those two were congruent. We didn't know for sure that they were congruent, but now that we do, we know we've got two that are 180. And then last but not least, we're going to go ahead and take a look at this rectangle, this green one I'm trying to highlight on the front right here. So I'm going to call that maybe the front. Try and outline that a little bit better for you guys. This is the piece I'm looking at right here. And I can see that that is 10 millimeters tall, and again, it is 18 millimeters deep. So those three all did end up being congruent. And then to finalize the problem, if we want the total surface area, we need to add all of these together. So I'm actually going to take 180. I'm going to multiply by 3 because there are 3 of them. Add the 86. And I am getting 626 square millimeters for this one. All right, I want to go ahead and jump down to number 6 now. And we are going to go about this process the exact same. I would highly recommend that you start with your triangles first. And then I'm going to write times 2 so I remember that there are 2 triangles. I'm going to try and do this one without doing as much highlighting, just so you guys can kind of visualize these. And so for my triangle, I need a right angle. And at the back of my shape here, I see that right angle. I see that this is a right triangle, and I can see that this is 6 meters here. So I'm going to multiply 0.5 times 6 times by. Now to follow the height of that right angle right there, I'm following this dotted line at the back here, which it doesn't have an exact label, but I can see that it's the same size as this one up front. So I'm going to use my 8. Multiply those to get 24. And then because there's a triangle at the front as well, I'm going to multiply by 2 to get 48. All right, so next up, I've got to find those 3 rectangles that are going around these pieces. Doesn't matter which one you start with. I am going to start with the bottom. And sometimes we all visualize these shapes a little bit differently. For me, when I visualize the bottom, I see this orange piece right here. And so to me, I'm going to call that the bottom, and I can see it's 10 by 5 meters. And so I know that the area of that bottom is 50. And then from there, I'm going to look kind of toward the back of this triangular prism here. And toward the back, I see this other rectangle here, and it's kind of smushed because this is the back of that rectangle. But I can really easily see, and highlight this a little bit better. Go. So I'm still, oh, maybe not. All right, well, I can see that this 8 right here goes with that back triangle. So I'm going to multiply 8 by, and sometimes highlighting can make these kind of hard to see. So I can see that 8 going up and down right here. And then I would say that the width of it is going to be 5 right here. And I'm pulling that simply from the front. I can tell that those are both going to be 5 to give me 40. So I highly recommend you guys use pencil. Sometimes when I end up tracing these pieces, I find it easier to go back and erase what I have outlined so I can visualize other parts. And then from there, I'm going to go ahead and take a look at the front of mine. And this one is super easy for me to see. I can see the 6 and the 5 right off the bat. And when I multiply, I get 30. And so for my total surface area, I will simply add those all together. I'm getting 168. And then meters squared because I'm dealing with surface area.